Okay, I think we should start with this session. Can you hear me? Can you confirm that the volume is fine?
Yes, I hear.
Thank you. Okay, so
Me
my
too.
name is, yeah? Okay. Thank you. My name is Alfredo Cardigliano. I will take care of 3 out of 5 sessions of this ntopng official training. Today we will see an introduction about ntopng and in general the ntop suite. We will see how to mainly what kind of problems we tackle with ntopng. We see a little bit of the ntopng architecture, so how ntopng is able to analyze the traffic, what are the interactions with other softwares, so how to integrate ntopng with other software. But this will be just an overview, and we will focus on how to feed ntopng with traffic information. So that can be packets, can be flows coming from routers and switches, how ntopng can analyze the traffic both in a passive way or in an active way. So we'll see how to collect packets and flows, but also how to get traffic information from SMP devices or using active monitoring. So first of all, let's see why we should use this software. What are the problems that we can solve and tackle with ntopng? First of all, if you want to have control over our network, so if we want an healthy network from both the performance point of view and the security point of view, we have to understand what's going on in the network. So for this reason, we need to monitor the network, see what kind of traffic is flowing in the network, who is using the network, who is connected to the network, and analyze what is the behavior of this traffic. So the main question that you usually want to answer using a monitoring tool like ntopng is about the bandwidth utilization. So who is using the bandwidth in the network? For instance, I want to know if there is any application which is not supposed to be in the network, which is actually present in the network, for instance, suspicious applications. For instance, maybe using ntopng, we discover that in our network there is some Tor traffic or BitTorrent traffic that we don't expect. We see that there is, for instance, traffic about Facebook or YouTube, and we want to know who is using Facebook. For instance, if we have a corporate network, the employees are not supposed to go on Facebook using the corporate network. We want to know why NOS is generating a lot of traffic in our network to optimize the network utilization, or like who is talking to whom. So if I have two hosts that are generating traffic, I want to know why. So about what protocols, what kind of applications they are running. Then you can answer also to question about the what we call SLA monitoring. So when you have a contract, an agreement with a service provider, an internet service provider, for instance, you usually pay to get a service, and the service provider should guarantee, for instance, a minimum bandwidth, or in case of a cloud service provider, it should guarantee a maximum, application latency. So with ntopng, we can check those parameters by looking at many metrics, by using active monitoring, as we will see later. So for instance, we can monitor over time the latency of a service, or you can use the speed test and check over time how the bandwidth changes, etc. To make sure that, again, the service provider is honoring what we negotiate. negotiated in the service level agreement. Or it happens that I see that internet is slow, my connection is slow, and I want to understand why. And this can be caused by several reasons. For instance, the link is congested, so I have a lot of traffic in my network, and some traffic is getting lost because of that. Or it can be that the network is fine, but the ISP is not providing enough bandwidth. Or I have enough bandwidth, but it's just a DNS which is taking too long to reply to our DNS requests. Or the DNS is fine, but it's the web server itself which is slow. And the web server itself can be slow because of the web server service itself or other dependencies like the database system. So we can answer to all those questions using ntopng. Or the internet is not working at all. This can be because I'm disconnected from the network, or I'm connected but didn't get an IP address, or the local router is not forwarding the traffic on the internet, or again, the DNS is not working, or the DNS is working but the web server is down. So there are many questions that we can answer with ntopng. And we can also monitor what is the status of our switches and routers in our network. For instance, we can check using SNMP in ntopng if there is any faulty port on the switch, if there is some port which is down, for instance, which is not expected to be down, if there are ports which are heavy loaded, for instance, if the utilization on a port is exceeding a certain threshold, we can also trigger alerts, for instance, to notify you. We can check, of course, how many ports are available on switch, because again, we can see which ports are in use and the status on each port. And we can see also who is connected to which port. So for each port on a switch in ntopng, you can see who is connected, which device, which MAC address is connected. And we also, especially in the last years, we are focusing on cybersecurity. This means that we have checks in ntopng which are monitoring the network to check the presence of anomalies. Sorry, I have to accept. ntopng can check for anomalous traffic, can check for infected hosts, for instance, can check for data exfiltrations, or can check for hosts which are accessing malware sites. We integrate with blacklists. There can be official blacklists available, like we will see a few examples later, or there can be blacklists, custom blacklists that you can build. With this, we can detect also, for instance, crypto lockers moving in our network. Or we can detect lateral movements. Lateral movements, for instance, in ntopng, we can track all the active services, and we can detect when there is a new service in our network that was not there until yesterday. And we are able to detect this activity and notify the activity. And we can also, we also have the network, an active discovery in ntopng that is used to build a taxonomy of all the active devices, of the devices which are connected to the network, and all the open services in our network. So who is providing what kind of service? So we are able to identify, for instance, if there are hidden devices which are not supposed to be connected, for instance, in a corporate network where I want to know all the devices which are connected, and I want to know to get notified when there is a new device, or the other way around, if there are some devices which are supposed to be always connected, I want to be notified when they are no longer present in my network. Okay, so this is the first view that you have when you run ntopng. We will see that we have many applications, but ntopng is the main one, the meaning that it's the application which is used to display traffic information, kind of a collector, let's say, that can be used standalone to process packets. So you can just run it on any PC receiving a copy of the traffic, or to analyze the traffic of the machine itself, and we show you what's going on in the network using a web browser. Or it can be used in combination with other piece of software like mprobe, which is a probe that you can use remotely to monitor remote sites, or that you can use to collect traffic information from routers and switches, able to export NetFlow, for instance, or SFlow. So this is the main view that you have in ntopng. I mean, let's say the first view, which is the dashboard, where you have really aggregated information. And we will see that we have many other pages in ntopng that can be used to analyze the traffic, to get traffic insights. This is really the simplest one, but this already answers to many of the questions that we have seen before. For instance, here we can see that we have the top local talkers. So this is answering to who is generating most of the traffic in our network. Here we have the top remote destinations. So what are the hosts, the remote hosts over internet, which are contacted by our local hosts and that are generating more traffic, towards whom we are generating most of the traffic. Then we can see what are the top applications used by our hosts. So for instance, here we see that there is some HTTP, MySQL traffic, so the layer 7 applications. And here we have the total traffic on the interface that we're using for capturing. In this case, we have two interfaces, so we have the total traffic per interface. And the same information for the last day. But again, this is just a simple view on the traffic that answers to the main questions, but this is really a small part of the analysis that we can do in ntopng. We will see a demo of ntopng during the next sessions. Today we will focus on the main features and how to get traffic information. Then we will see later how to analyze those information in ntopng. So we've seen that ntopng has a web-based user interface, which is what we use to navigate the data, to visualize the data, to configure ntopng. ntopng then can export events using an internal alerting system where you can configure, for instance, several endpoints, like you can get a notification on a messaging system like Slack, like Teams, Telegram, and others. You can receive notifications by email, or you can configure ntopng to call a webhook or to run a script like a bash script that gets all the information about the event, and you can automate an action. Traffic information are stored into time series database, which is RRD by default, or you can optionally enable also InfluxDB for high cardinality. And we can store historical data to a database, which is ClickHouse, which is similar to MySQL, but is much faster, really optimized in terms of performance and disk utilization, and contains native data types like the IP address. So this is really optimized for network data, and can be optionally enabled in ntopng to keep not just the real time and not just historical data about time series, but to keep the raw data. With raw in this case, I mean all the network communication for the past traffic. You can ntopng can do malware detection. For instance, we integrate with blacklists like those built from emerging threats or Cisco Talos or others, or you can build custom lists. It integrates with our deep packet inspection engine, which is NDPI, which is the library which is able to provide layer 7 information. For instance, first of all, for each network communication, we are able to tell if this is Skype or Facebook or any application protocol, and can provide also additional metadata. So for instance, for HTTP, we can tell you what is the host name, for instance, for the user agent, or based on the protocol, we provide different metadata. Or for TLS, we tell you the server name, etc. As we said, ntopng support SNMP to get information from routers and switches, and also integrates with mprobe to be able to monitor networks using NetFlow or RESTflow, which is a technology. They are technologies usually available on routers and switches to export traffic information by means of flow metadata. But we will see in detail what is NetFlow and how it compares with processing packets from a mirror port, for instance, of a switch, versus also SNMP. And then we support also active monitoring. So active monitoring means both discovering devices in our network using active techniques, so injecting traffic in the network, like scanning a network, but also checking the performance of the network. For instance, running a speed test or running checking the latency of a service using HTTP requests, for instance. Of course, please stop me if I go too fast. We want this to be as much interactive as possible. So if you have questions, please raise your hand and ask. Okay, so let's see what is the big picture. So the ntopng architecture, let's say. So we say that ntopng can ingest packets. For instance, we will see later in this presentation how to get packets from a mirror port or a span port of a switch. It can process a pickup file. A pickup is a standard for dumping packets to file, which is the same file format used by TCP dump or Wireshark, for instance. And you can run ntopng on top of a pickup file if you have a pickup file that you created from the traffic of your network, and you can analyze it with ntopng. Or ntopng can be used to collect, as we said, NetFlow or SFlow exported from a switch or router in your network that can be translated from using our mprobe software into traffic information that ntopng is able to understand. So this product, so mprobe, is acting as a proxy and doing the translation, the conversion from the NetFlow format to, let's say, JSON that ntopng is able to understand. We say that ntopng can use blacklists to detect, for instance, if communication is about an host accessing a malware site. I see that there are questions. Let me see. It's possible to collect and export network devices discovery results with information are connected during the discovery. Do you mean exporting in which format? I mean, at the moment, I don't think we have any export format for the device discovery. It's just something, an information that we display in ntopng. Again, we can talk with SNMP devices to get information about the status of a switch, so the status of each port of a switch, for instance, and counters. So with this integration, with the SNMP integration, we get just in terms of traffic monitoring, we can get just counters, so like packets and bytes, which are crossing a port of a switch. That, of course, provides less information rather than processing packets or flows. But here we have additional information, like if we have a switch, we can check again the status of all the ports on a switch. We can see the load on each port, and we can see which device is connected to each port. So this provides additional information with respect to processing just the traffic packets and flows. We say that we can export alerts to several endpoints. We mentioned a few already. We can dump historical data to a database, ClickHouse, we have seen this. We can also integrate with IDS systems like Suricata to ingest alerts. This is useful if you want to use ntopng for cybersecurity, because ntopng is already able to detect security issues, but with Suricata you can also match traffic against CVEs. So with Suricata you can do signature matching, which is something that ntopng is not doing. So you can have in a single solution both traffic analysis, traffic visibilities, traffic checks in ntopng, and signature matching using Suricata. We say that ntopng is using RRD or InfluxDB for time series, and in addition to traffic information, so in addition to storing time series to InfluxDB or RRD and flow information to ClickHouse, so metadata about all the network communication, you can also store the raw traffic, that means raw packets to disk in pickup format, integrating ntopng with N2Disk. So with this configuration, this is an optional configuration, and this configuration ntopng can record all the traffic to disk, and when something happens, for instance, if you get an alert about a security event, you can go back in time and drill down up to the packet level, so you can extract the pickup file matching that specific event, for instance. Yeah, I can see Luca answered about the discovery. So Yeah, that information is stored on Redis, so you can access that using directly ntopng or through Redis. So today we say that we will focus on how to get the data, so how to feed ntopng with traffic information. So we say that we can process directly ntopng packets from a network interface. That means that we can connect this network interface, a mirror or a span port of a switch, and process live traffic. We can process packets from a pickup file. We said we can query, we can use SNP to get counters from a switch or the status of the ports, etc. Or we can get traffic information from our sensor, our probe, which is mprobe. This information is exported from mprobe over ZRMQ, which is like a TCP connection, in JSON format or in other optimized formats which optimize the bandwidth utilization to export the metadata. And the probe itself can get traffic information, again, from packets. For instance, if your local ntopng instance doesn't have access to packets because the packets are on a remote location, you can use mprobe on the remote location to process packets and export traffic information using ZRMQ from this remote location from mprobe to ntopng. If you have a centralized ntopng, for instance, and a distributed network, you can distribute many probes in your network and send this traffic information to ntopng. Or if you have network devices like switches and routers able to export NetFlow, you don't want or you cannot access packets, you can use you can collect NetFlow or RESTflow from the switches using mprobe and send traffic information to ntopng. So in this case, mprobe is converting the information. Just to show you a few examples that we will focus on this during the next session. We will see how to configure ntopng, but I want to show you a few examples. So when you run ntopng, you can configure it with this option -I, which is the interface to capture traffic directly from a network interface. For instance, to analyze the traffic of the same box or traffic coming from a mirror port, which is connected to this interface of the machine. Or you can configure ntopng using the same option to analyze a pickup file. Or you can use ntopng to receive traffic information on this ZRMQ socket, which is running over TCP, where you configure the IP address of the probe and the port, and you run the probe capturing traffic from an interface or collecting, we will see how to do that, to collect NetFlow from a router, and exporting traffic information to ntopng using, so you configure the endpoint where you want to export the data, you connect mprobe to ntopng. So we say that we can get counters from SNMP, flows from routers and switches using NetFlow or running mprobe, or we can analyze packets directly. So let's see what are the differences between those methods, what are the pros and cons of using those methods. There is another answer. So they're asking, is the connection over the network of mprobe and ntopng encrypted? So mprobe and ntopng communicate using a ZRMQ channel. This can be optionally encrypted, yes. So you can configure ntopng and mprobe using a parameter to encrypt the data. And in that case, ntopng generates a public key that you have to configure in mprobe. and probably use this public key to encrypt the data, so that ntopng is the only one able to decrypt the data, because ntopng has the private key. So yes, it can be encrypted and also compressed. It's compressed by default, but you can also disable that using an option. Okay, so we have seen that there are different technologies to monitor a network: counters, flows, packets. By default, sorry, there is another question. By default, the channel is not encrypted, but you can enable that using a parameter. Yeah, and the same applies to Kafka, because now you can also use Kafka in mprobe and ntopng as communication channel. So you see that there are several technologies. We can divide them into passive and active. Passive means that I'm passively getting traffic from the network, for instance, using a mirror port and a switch and getting packets, or using NetFlow and receiving flow information from the network. So I'm not injecting traffic into the network. So I cannot change the traffic into a network. So it's something which is really non-intrusive. It's that doesn't add issue to the network, let's say. And doesn't affect the performance of the network or the security of the network. And then there are active technologies. An active technology is something like a speed test, which is actually injecting traffic because it's running a test in the network to get the result. And then we can divide those technologies into coarse-grained versus fine-grained. For instance, the coarsest grained technology is, of course, SNMP, for instance, where I get just packets and bytes, so counters about the traffic. The finest grained is the packet, which is really the raw data, and provides, I mean, it's the technology the technique, let's say, that provides more information, because I can access even the packet payload and check every single bit of the communication. So let's see what are the pros and cons of each technology. So we say that packets is the finest grained technology. We say that packets never lie, because, I mean, it's the raw data, so it's actually what's flowing in the network. The problem with packets is that on a network, on a modern network, we have many packets per second. If you consider even a 1 gigabit link, at 1 gigabit worst case, so with small packets, you can have up to 1.48 million packets per second, which is a lot. You can imagine at 10 gigabit, which is almost 50 million packets per second, or 100 gigabit. So if you have to look at the packets manually using, for instance, Wireshark, that's really a lot of traffic, and it's impossible for an analyst to analyze the network. It depends what you have to do. So if you are interested in traffic information like bandwidth utilization, it's better to use a tool which is analyzing packets or NetFlow to show you what are the network utilization, who is using the network, what are the protocols, etc. Then if there is an incident or an event, a security event, or you have to troubleshoot, and you want to drill down up to the packet level, then you can do that. That's something that you can do applying filtering on the traffic. So inspecting packets directly is complicated, but it can be done if you have a tool like ntopng, which is visualizing traffic information and lets you drill down up to the packet level. So the actual, but of course, the tool, so ntopng or mprobe, can process packets and extract traffic information from packets. So, for instance, we will see in a moment what is a flow. So a flow is a way of converting packets into metadata, so reducing the information and showing you what is the let's say really the metadata means the information about the communication without having to look at every single packet of the communication. For instance, if we open Wireshark and we start capturing the traffic, we see a lot of packets, even for a single communication, like in this case. So in this case, we can see that this is a TCP session with a tree shake at the beginning. So since in a hack, then there is a request of web page and a lot of data and hacks. So we can see that those are the packets exchanged for a single communication. So we can imagine if we have if you are monitoring an entire network and we have a million packets per second, so it's impossible to analyze them manually. But again, we can analyze packets using ntopng or mprobe. So how to get the packets out of our network? In order to get the packets, there are several technologies. The simplest one is to use a port mirror or a span port of a switch. We will see how to configure that. And there are also remote variations like the airspan, and a new piece of software that we developed in the last months, which is ntop. With ntop, you can, for instance, configure on a this software on a machine or a network interface, and this software will forward the traffic on this network interface to a remote machine where there is a collector that is able to provide this traffic to the monitoring application, or where you have mprobe or ntopng, for instance. And you can also filter this traffic, so you can tell I want to forward the traffic on port 80 on this network interface of this box to this remote box, which is running the monitoring software. Then there are physical taps, network taps. We will see what they are in a moment, and packet brokers. So let's start from the port mirror. Let me see, there is someone. Okay. So what is a port mirror? If you have a switch, usually, I mean, unless you really have a really cheap switch, the switch is able to forward on a specific port a copy of the traffic that you see on other ports of the switch. So for instance, if you have the switch and you have a few machines connected to the switch, you can configure the switch to send a copy of the interfaces where those machines are connected to this egress interface, where you can connect your monitoring tool, for instance, ntopng, that is receiving a copy of the traffic which is exchanged between the machines in your network, and can analyze this traffic and show you traffic information. Now, if you configure the port mirror on a switch, you have to pay attention to this the configuration of this mirror, let's say, of the traffic, because if you consider in this example, we have two hosts which are connected to the switch, and those connections are, of course, full duplex. That means that an host can send and receive traffic from a port of the switch. This means that if the host A sends traffic to host B, this traffic is entering the first port and leaving the second port. So this means that if we configure the port mirror on the switch to copy both ingress and egress traffic from all the ports of the switch to this monitoring port, we will receive twice the same packets, because this packet is packets from host A to host B are entering the first port and leaving the second port. So we'll copy the packets entering here and leaving here. So it is important to pay attention to this when configuring traffic mirror, port mirror, because you can, we'll see how to do that. We can configure whether we want to copy to the monitoring port just Rx traffic or just TX traffic, or Rx and TX. So a good practice is to configure, for instance, just the ingress traffic or just the egress traffic when we configure the mirror, to avoid this double copy of the traffic. Unless you are monitoring, for instance, the link which is going to the router or the firewall. In that case, you monitor a single link and you can monitor both ingress and egress traffic to get the full traffic. Okay, I want to show you how to configure, just to show you an example, how to configure a switch. This is an HP switch. So let me connect to a machine in my network. We'll use telnet to connect to the switch. So I will connect to the IP address of the switch. I go into the menu of the switch. And here I can go to the switch configuration, then to the network monitoring port, which is again the port mirror configuration. Here I can specify if I want to enable the port mirror. I can specify what is the monitoring port, so the port where the copy of the traffic is sent. And I can select which ports I want to monitor. So I can select here the actual ports that I want to, where I want to get the traffic and send it to the monitor port. So after configuring this, we have, in this case, port 26, which is where the traffic is sent. A copy of the traffic is sent. What you have to do is to connect your machine running ntopng, for instance, this port 26, and run ntopng on the network interface which is connected to this port. So for instance, in this case, this is an example, we run ntopng, and we specify as the interface the ENO1, which is where we receive the traffic. So this is the, let's say, the simplest way to get traffic using packets from a switch and run ntopng to analyze the traffic. Is it clear? Any question? Let me check if we have questions in the chat. No, you're good. Now we've seen the mirror. Let's see how a tap works instead. So a tap is a terminal access point, which is an hardware device that can be used as a bump in the wire. That means that if you have, for instance, a connection between two routers, a router and firewall, a router and switch, if we have a link, a full duplex link, we can put the tap in the middle, so we can disconnect the cable from one of the two devices, connect to the tap, and from the tap to the second device. So the tap is forwarding the traffic between the two devices, and at the same time, the tap is sending a copy of this traffic to our monitoring tool. And this is done using two interfaces, because a tap is really a transparent device. So if you have a full duplex link, we will have a link from A to B and one from B to A. And in order to send a copy of this traffic, a tap is using two egress interfaces. So one for A to B and one for B to A. So when we run the software, when we run ntopng to get this traffic, we will use two interfaces on the machine, and we configure ntopng to aggregate the traffic from those two interfaces into a single interface and provide a single view in our web user interface with traffic information. Now, what are the pros and cons of using a tap versus a switch? In a switch, we have seen that we get traffic information from a single interface, so we don't have to aggregate, like in the tap, the two directions using two interfaces in ntopng. But the fact that we are using a single port in a switch to send traffic information about multiple ports in the switch, this means that the total amount of traffic that I'm copying to the interface should not exceed the interface speed. So for instance, if I have a switch with 10 gigabit interfaces and the monitoring port is 10 gigabit, if I have two hosts which are generating even using two single ports on the switch, if they're generating 10 gigabit from A to B and 10 gigabit from B to A because the link is full duplex, I have a total of 10 gigabit per second, which is already exceeding the speed of the monitoring port. So I have to pay attention that the total traffic that I want to monitor doesn't exceed the speed of the port that I use to monitor the traffic. In fact, usually if you buy a switch, usually you have switches, for instance, with 1 gigabit ports that have an additional 1 or 2 10 gigabit interfaces that you can use for monitoring. But again, you can imagine that if you have even switch with 1 gigabit port, but if you have 24 gigabit ports, you can have up to 48 gigabit per second. So you will exceed the 10 gigabit port anyway. So you have to pay attention to what you want to monitor and that this traffic doesn't exceed this threshold. Instead, with a tap, you don't have this problem because if you have a 10 gigabit link, for instance, you can have up to 20 gigabit, 10 gigabit per direction, but you're using two ports, one per direction, so you don't have this bottleneck. Please let me know if everything is clear. So I see a request. Is mirror port a recommendation to use a router or firewall? Yeah, as Luca said, mirror ports are available on switches usually. So if you don't have a mirror port on a switch, you should use a tap. Yeah, but they are usually available. I mean, unless you're a really cheap switch. But a tap, I mean, if you have a cheap switch, probably it's better to replace the switch rather than buying a tap. Okay, then we can have active taps or passive taps. So active tap are devices that require electricity to work. And they're usually used with copper links. So if you have copper links and you want to put a tab, you should buy an active tab. And because this is requiring electricity for forwarding the signal from the router or firewall to the switch in this case. So from port A to port B, and at the same time send a copy of the traffic to two additional ports, in this case C and D, where we connect our ntopng. A passive tap is a device that doesn't require electricity, doesn't require power connection, and is usually used with fiber links, where the tap is usually implemented as an optical splitter that is using the reflection to send a copy of the signal to the other interface and the same copy to the monitoring port. So this is exactly the same as the active tap, but this is passive. Now, when we talk about passive taps, we have to pay attention to the light attenuation. In fact, if we have a link, for instance, again, from a router and a switch, for instance, we have the SFP on the router, which has a certain transmission power, and the SFP on the switch, which has a certain receiver sensitivity. So this means that we have some power budget, which is the delta between the sensitivity of the receiver and the power of the transmitter. And we have to make sure that we have enough power on the receiver to be able to receive the signal. Now, if we consider the link between the sender and the receiver, there are several attenuation of the signal. So we have an attenuation for the connection itself, so the connection of the fiber into the SFP. We have the attenuation of the cable that depends on the type of the cable, depends on the length of the cable. And if we introduce a passive tap, we introduce an additional attenuation, which is what we call the splitter loss. So we have to pay attention that the total attenuation doesn't exceed the power budget, otherwise the link goes down. So when we buy a tap, we have to pay attention to this. In fact, there are different splitters, different tap devices. You can check the specs of the tap, and you can see that there is a split ratio, for instance. In fact, there are splitters which are 50-50, 60-40, 70-30, which is the ratio of the between the signal that goes on the main link and the signal that goes to the monitoring link. So if we want to make sure that the main link doesn't go down, we usually prefer a splitter with a ratio like 60-40, 70-30. But let's say at 1 gigabit per second, on links at 1 gigabit, we usually don't have problems with attenuation, and we can use a 50-50. If we are monitoring at a gigabit link, then the situation changes a bit. We should prefer like a 60-40 to make sure that the link on the main link doesn't go down. Worst case, we will lose the link on the monitoring port, but at least we don't interrupt the network communication, let's say. If my router firewall support more mirror port, is it recommended to use it? Okay, let's see. Luke already answered to this. Then there are the packet brokers. Packet broker is a device that you can use in combination with spam port, mirror ports, or tap devices that can aggregate, for instance, traffic from multiple sources like taps, again, or mirrors, and then can provide this traffic to multiple monitoring tools, or can, in case of high traffic, can, for instance, be used to load balance this traffic to multiple instances of the tool. For instance, in this case, this example, we can see that we have a tap, which is getting the traffic from the router to the firewall, sending a copy of the traffic to the packet broker. The packet broker can do the aggregation, for instance, aggregating the two directions of the traffic from the tap device or traffic from multiple taps. Can do filtering, so we can filter out traffic which is meaningless for us, or can filter traffic which is interesting for us, and can, again, load balance or send a copy of the traffic to multiple monitoring tools. So we say that processing packets is, let's say, should be used as a last resort. Let's say if we have to analyze the traffic manually. So if we want to really analyze packets using tools like Wireshark, because we have many packets per second in our network, we should at least filter this traffic using tools like ntopng, where we can analyze the traffic, see what's going on in the network, and drill down from charts, network communications, events, up to the packet level. But they can be analyzed by the tool. So we can provide a copy of the traffic using the techniques that we have seen right now, and provide those packets to ntopng or mprobe, which is able to process the traffic and extract traffic information. Now, we're seeing that packets can be compressed into flow information using the tools, or we can get net flow directly from routers and switches. So what is a flow? A flow is representing, let's say, a network communication. So for instance, if you have TCP session, for instance, if you do an HTTP request to download a web page, that's a TCP session. And a flow consists of all the packets which are exchanged by our client to get the page. For instance, a flow is all the packets necessary to download a web page, or all the packets necessary to carry the voice in a voice over IP call. This flow is identified usually using what we call the file tuple. That means source and destination IP address, source and destination port, the protocol, and in some cases other information like the VLAN. Then there are metadata in addition to this file tuple, which is, in the, for instance, packets and bytes exchanged, or layer 7 information, like for HTTP, I can have the URL, the user agent, etc. So in the previous example, where we were analyzing packets for an HTTP request using Wireshark, we can see that we have many packets that are all about the same single HTTP request. And if we translate those packets into a flow, it's a single row. This is from ntopng, for instance, where we have the client, IP and port, server, name and port. We have the protocol, TCP. We have the application protocol, which is HTTP. We have the duration of this network communication, the traffic breakdown, the total number of bytes, information about this network communication. So in this case, we have the URL, and we can have additional metadata. So in ntopng, if we click on this info button, we get many metrics about this network communication. So we're able to process the packets and extract metadata to show you a summarized information for this network communication. So how to get flow information from our network? So we say that we can use the software, so mprobe Pro Enterprise or mprobe CentOS. We have two different softwares. We will see them in detail. So we can use our sensors to get the packets, classify them, and export flow information to ntopng, for instance. Or we can collect net flow or ipfix or sflow from routers and switches. And we can use, in this case, mprobe to get the net flow, translate, convert it into JSON over ZMQ, and provide this information to ntopng. The main difference between the two technologies, so collecting net flow from a router or extracting flow information from packets is that when we use net flow, we usually get basic information. For instance, we get the 5 tables, so NP, port, protocol, etc., and little metadata, so few metadata like packets and bytes and some more metadata. Instead, if we use the software like mprobe or ntopng directly to capture packets, we can use our deep packet inspection library and DPI and extract many more information from the packet payload, including, for instance, for HTTP, we can extract the URL, the user agent, the cookies, so information which are contained in the packet payloads. Of course, if we have a box which is processing packets, this requires the overhead of this box would be higher with respect to a box which is connecting NetFlow, because NetFlow already contains summarized information. Instead, when we process packets, we have to analyze millions of packets per second. So this requires a faster CPU, let's say, for instance. And of course, it requires access to the packets. So we need a mirror or a tap in order to run mprobe or ntopng on packets. Let me check the chat. Okay, I see that Luca is already answering to the questions. If you want to discuss, please open your microphone and ask. Don't be shy. Now, if we want to collect flows in NetFlow format from our routers and switches, we can use mprobe. We can connect mprobe to ntopng to visualize the data. So this is an example. We will see this in detail, but in essence, we can configure our router to export traffic information towards a machine in our network on a specific port. On this machine, we can configure mprobe, which is configured to collect, in this case, NetFlow traffic on port 255, and to send this traffic information to ntopng on the same box. On the same box, so localhost on port 5556. Then we configure ntopng to receive traffic information on the same port. So in this case, mprobe is collecting NetFlow and sending flow information to ntopng using this TCP socket using ZeroMQ. Now, yeah, I want to show you just, again, a simple example, just to have an idea of how to configure a router to export NetFlow. So we can connect to a small router that we have in our office. This is an EdgeMax from Ubiquiti. So in this case, we are logging to the router. We can go to the configuration tree. We go to service, no, it was system, flow counting, and here we have NetFlow. So in NetFlow here, we can configure the servers that should receive NetFlow information, which are the servers where we will run mprobe to get NetFlow. So in this example, we configured a couple of IP addresses. So just to show you, let's connect to this one. So this machine now is receiving net flow from the router. So we can check this even using TCP dump. So for instance, TCP dump, specify the network interface or the management interface of this machine. And I want to filter for UDP because net flow is sent over UDP, and port 255, which is the default port for net flow. Enter. And as you can see, this machine is receiving net flow traffic, so UDP port 255 from the router, which is 2.1. Now, on the same machine, just to show an example, then we will see this in detail, I can configure and probe. Let me show you the configuration file. I can configure and probe to collect, no, this is another instance. I can configure and probe to receive net flow on port 255 and to send traffic information to ntopng, which is running on the same box. It's collecting data, flow data on port 1235. On the other side, I have ntopng, which is configured with an interface which is receiving, sorry, the interface was 1235. So on the other side, I have ntopng, which is configured to collect flows on port 1235. Now, if I connect to the user interface of ntopng using the browser, the IP address of this machine was .178 on port 3000 because ntopng is listening on port 3000. Again, we will see a demo of ntopng in the next sessions, but I just wanted to show you the full path from the router to through mprobe to ntopng. So I log into ntopng. So now we have this router, which is sending net flow data to this host, which is running mprobe, and mprobe is sending information, traffic information to ntopng through port 1235. So I can select this interface, and here I see that I have traffic information. I can go, for instance, to flows and see all the network communication. So all this data is sent by the router to this machine, and it's visualized by ntopng. Now, let's come back to the slides. Okay, so when should we use flows rather than packets? So we say that we can analyze packets directly in Wireshark, but this is not possible at high rate because we have many packets per second. But we can still analyze packets using mprobe or ntopng and provide traffic information. Then we have the option analyzing packets versus analyzing net flow. So net flow is fine where we want just to have an overview of the communications or the traffic utilizations in our network. But if in some cases where we want to drill down at some point from traffic information in our ntopng user interface up to the packet level, if we want to do that, we have to process packets. Using NetFlow is not an option in that case. Or if you want to inspect the packet payload to get layer 7 information, or for instance, in ntopng, we have several checks which are able to inspect the traffic to trigger events in case of security issues or other issues. Some of them require access to the packet payload because they require our deep packet inspection library to access the packet payload. So in essence, accessing packets is better usually than accessing flows, but in some cases, accessing packets is not possible. For instance, if we want to analyze, I don't know, remote location where we don't have access to a mirror port or a tap, in those cases, we should use NetFlow. Then we have the other technology that we mentioned before, which is about looking at counters, which is in practice using SNMP to get traffic information from switches. SNMP, we say, that provides basic information because it provides just bytes and packets sent and received by the ports of a switch. It doesn't provide information about the content of the traffic, so about the hosts, the applications, etc. But it provides information about the status of the ports, so it's helpful in some cases to know what is, for instance, the load on a port, if a port goes up or down, if there are errors on a port. So to have an insight into the health of a network from the physical point of view, physical perspective, but also to know which device is connected to a port of the switch, for instance. And in ntopng, we can trigger alerts when, for instance, a port goes down or when a port is too much loaded. So, for instance, if the load on a port is exceeding a certain percentage. This is an example of the view that we have in ntopng, where we go to the SNMP menu in ntopng for a selected device. So in ntopng, we can configure ntopng. We'll see this in the demo. In the next session, we'll see that we can configure our SNMP devices, so the switches in ntopng. ntopng will periodically poll them. So we periodically contact the switch and get information about the ports, for instance, and we'll build this view where we have, for instance, a page with all the ports interfaces on the switch, and for each port we have the interface name, the speed, the actual speed on the port, if it's up or down, and other information, for instance, also the MAC addresses connected to the ports. Now, how to configure SNMP on a switch? Let me show you also this. So let me again connect to a switch that we have in our office. This is easy, so we go to the SNMP configuration, to the communities, and here we already have a configuration for SNMP, but in essence, you just have to specify, let me show you here, you specify where SNMP should listen, for instance, all interfaces, all IP addresses of the switch, and you have to specify a community string, which is what you use in ntopng to get information from the switch. So for instance, you can specify ntop here, like in this example, and you will use the same community string when you configure in ntopng the SNMP device. So you have the IP address of this device and the community string in ntopng. And after that, ntopng will start polling this device. I will show you the information that we've seen here, in addition to other information that we will see in the next sessions. Then we have the active monitoring. Again, I have just this slide for the active monitoring because we will see this in a demo. But in essence, active monitoring, we have seen today different techniques. So how to capture packets, how to capture NetFlow, how to get information from the switch using SNMP. All those technologies are passive technologies. So we are not generating traffic to get information about the performance or the security of our network. With active monitoring, we are actually generating traffic. And we use this to monitor, for instance, with the device discovery to check the presence of a device. So to have a taxonomy of the devices in our network. But we can use this also to check the status of a service. So for instance, we can ping or do a request towards a machine or a specific service on that machine to check if it's up or down, to check the performance of the service, check the throughput, to check, as we've seen before, for the SLA monitoring, we want to check what is the available bandwidth, for instance. So we can check the throughput, we can check the latency of a service. For instance, we can do pings, we can do HTTP requests and check the latency. We have several checks in the active monitoring section in ntopng that we can use to monitor both hosts or services, or again, the performance of the network and the bandwidth. Okay, this was the last slide. Before the questions, I want to tell you that we have an image, a virtual machine that you can use to, if you want to play with the tool, you can download the virtual machine. This is like a small Linux box running our software that you can download from this link. I will send this link in the chat. Yeah, I sent the link in the chat. You can download this virtual machine, which is in OVA format that you can use with almost any hypervisor like VirtualBox or VMware. In the next session, we'll see how to run it. In essence, you have just to import this file into your hypervisor, run it. And after this session, I will send you an email with the Pro ntopng Pro license that we give for free to the attendees of this training. And you can install this license on the virtual machine that we provided, or on any physical box that you have, which is running, of course, a supported operating system. We support actually almost all the operating systems like Ubuntu LTS, CentOS, Debian, Windows, so FreeBSD. So you are free to run this license on any physical box that you may have, or on this virtual machine. You are free to generate the license and install it directly, or we can do that together in the next session if you need help with that. Okay, so if you have questions, please raise your hand, open the microphone. We have more than 5 minutes left, so we have time for questions. Will you also provide a slide file via email? Yes, after this session, I will send, after each session, let's say we send a PDF with the slides, so don't worry about that. You're welcome. Any other question? Okay, so it seems everything was clear. Great. Okay, the next session will be on Tuesday. We will talk about the installation of the software on Linux, Windows, FreeBSD. We will see, yeah, of course, how to run the software, how to configure the licenses, a little bit about the hardware sizing. Okay, Clark is asking, how does corrupted packets handled by ntop? Yeah, as Luca said, if you have a corrupted packet, they are usually identified by the network adapter and discarded. So, yeah, what you can see in that case is that the errors on the port of the switch are increasing, and you can detect them with SNMP. Thank you. I see another question. Is it possible to check if there is network problems like a DNS problem? Yes, you can analyze the traffic with ntopng, and we have what we call, so ntopng is able to highlight issues about DNS, and we have also checks that warns you, for instance, if a node in your network is using a DNS server which is not supposed to be used by, for instance, in a corporate network where you want to enforce a DNS. So we will see a few demo about this in the next sessions. Thank you. Okay, I think we can close this session. So see you on Thursday for the next session for part 2. Have a nice day.
Thank you. Bye.
Thank you. Bye-bye.